Industrial control systems are going through a digital transformation, from traditional air-gapped environments to more interconnected and automated systems. Call it Industry 4.0. Initially, ICS adhered to the Purdue model, where networks were isolated for security. However, with the rise of cloud computing, it's causing a shift towards asset-centric models, where data flows freely to optimize business efficiency. This transition includes the goal of making controlled decisions from the cloud, minimizing human intervention. This is seen in the lights-out plants that are fully operated by robots today. Industries, such as manufacturing and utilities, are digitizing physical assets like PLCs and robots, enhancing both the efficiency and safety, and unwillingly opening the door to exploitable vulnerabilities. Many industries are still in the early stages, with around 70% of industrial control systems still operating in air-gapped environments, often due to the long life cycle of expensive production equipment. So there is still time to secure these. How? One way is by focusing on known exploited vulnerabilities, rather than attempting to patch all the vulnerabilities. With over 250,000 vulnerabilities identified, security efforts should prioritize around the 1,500 known exploits, as recommended by CISA, for more effective risk reduction. Unfortunately, the Critical Infrastructure Security Agency, CISA, is under fire from the new U.S. president, with existing staff purged for political reasons. This calls into question optimism about continued bipartisan efforts in cybersecurity, especially those under the Biden administration, which maintained a focus on cybersecurity initiatives such as the Cybersecurity Review Board. At the moment, I remain cautiously optimistic that even with the potential regulatory upheaval, the momentum we have built over the years, along with a strong recognition of cybersecurity's national importance, will continue to be a driving factor in progress towards securing critical infrastructure. This is a story about the evolution of industrial enterprises as they transition through digital transformation towards Industry 4.0, and what a new report has to say about that journey so far. I'm Robert Famosi. This is Error Code.
I am Grant Geyer, the Chief Strategy Officer for Claroty. Claroty has unique insight into the assets, vulnerabilities, and risks associated with cyber-physical systems so that we can help organizations intelligently mitigate those risks within the environmental, operational, and risk-based constraints within asset-intensive organizations.
In February 2025, Claroty released a report, State of CPS Security 2025, OT Exposures, in which they looked at vulnerabilities and their exploitability within roughly 1 million OT devices out in the field.
So this data set was, I'll say, a point-in-time snapshot, I think, from around Q3 of 2024. What we're looking to do going forward is we're pulling this snapshot every month so that we can look with the same set of customers and the same devices, how they trend over time. Are organizations becoming more effective in their strategies to mitigate risk, or are things getting worse as more vulnerabilities and exposures are discovered?
In this report, Claroty focused on some industries in particular, including manufacturing and transportation.
Yeah, so I'll say broadly speaking, we kind of segment the market of asset-intensive enterprises into 3 segments. The industrial segment, which is in scope of what we're talking about today, the healthcare segment with like medical devices and building automation systems and building management systems like elevators, escalators, refrigerations, things that you wouldn't want to go out in a hospital. And the third is the commercial segment, and that's like data centers, retail, hospitality, organizations that really kind of rely upon the building automation system and security infrastructure. But all 3 segments have cyber physical systems in it. Now, the scope of this report was around the industrial enterprises. And there, the thing is, like, for years in my career, I spent time focusing on IT security. And in IT security, financial services IT environment looks the same as healthcare IT environment, looks the same as manufacturing. Because in the world of cyber physical systems, it touches the physical world, there's so many nuances around the business related to the OT infrastructure. So we bucketed them into four different groups. There's manufacturing is the first. The second is natural resources. Think oil and gas, pulp and paper, materials, mining. The third is warehousing and transportation, or logistics and transportation. And the fourth is power and utilities. Now, power and utilities, the sample size wasn't big enough for us to get statistically significant or statistically reliable data. So with this report, we put it outside, and the next report will probably include it. I'll say for the three that are in scope of this report, we actually drill down to about 40 different subverticals. Think like in manufacturing, we look at food and beverage, we look at auto manufacturing. We look at consumer packaged goods, and we find even nuances there. And we're going to continue to have more and more results at a much more sub-segmented level as our data pool continues to grow over time.
When we think about verticals in cyberspace, we might discount that because we know networks. Networks are pretty uniform across the board. But when you get down to the OT space, what are the devices that you typically find in each vertical? They're specific or proprietary. How are they different from your traditional routers and switches and so forth? So in this report, what is Grant looking at?
Well, let's even take a step back further from that. This is like the super fascinating part of industrial enterprises and their journey through digital transformation to Industry 4.0. Like in days of yore, the philosophy was air gapped. I've never actually seen a fully air gapped environment, whether it's through design or inadvertent. There's always some connection into IT. But the intent was that they would be physically separated, air gapped, and stratified into different levels of security that we know as the Purdue model, right? And that was kind of the philosophy that you can only make a control change one level down, but data can flow up seamlessly for reporting purposes and management purposes up seamlessly from bottom to top. That is a world that is in the midst of a massive shift and a massive disruption. Why? Because now there are so many advantages to be gained from IT technologies and cloud-based technologies that there's a dissolution happening within these organizations so that data can flow up to the cloud. And it's less of a network-centric model and more of an asset-centric model. What assets need to talk to other assets seamlessly so that business can gain the efficiencies created through digital transformation. Where this is going is that control decisions will eventually be made from the cloud within certain safety parameters and control parameters so that you don't need to have humans in the loop. Now, that may sound scary to practitioners at asset intensive organizations, but we see that happening. Like one of our companies is in the meat packaging space. And it turns out a job that nobody likes to do is pork belly production. Turns out that they're very heavy, very hard to carry around. It's really time-consuming work, messy work that needs to be done. So this company I talk with has a plant, and they're really kind of leading edge. They have an entire lights out facility, meaning there are no humans in the facility. It's entirely robots top to bottom that are running the process 24/7, except for certain downtime windows. So I kind of painted for you 3 different stages on this journey from air gapped to transforming to fully transformed. Now, the reality is for all of the multinational large enterprises we looked at, they cover the entire range. You'll find a plant in Malaysia is still air gapped in the Purdue model, while their plant in Geneva is a lights out plant. Like they're at the entire range. And I think that's part of I'll say the challenge is because of long technology obsolescence cycles, which we'll talk about in a second when we talk about assets and vulnerabilities. A CISO and OT engineering teams need to think about driving business results, and at the same time, securing the assets and securing the process within the context of those different stages in time at which the different plants are. So I know I didn't answer your question, but I think that's important framing to talk about the journey that we're on.
Often, when I explain to people, OT can be a conveyor belt, it can be an elevator, and it could be a very specific robotic arm in a manufacturing plant.
The range of assets that you see in asset intensive enterprises within OT span an enormous range of capabilities. Think that at one end of the spectrum, you may have process manufacturing. Think of a steel foundry where the most important asset in that foundry is the blast furnace. That blast furnace has been there for the past 10 years. It'll be there for the next 20 years. There's, the environment is statically assigned in terms of IP addresses, but that's one example of a programmable logic controller is an asset that can change the temperature of the blast furnace. It can sense the temperature of it. There's also the steel that comes out of it, trying to make sure that there's the right mix of materials within that steel impacts the quality and whether it can be used in bridges or tunnels or buildings. And so there's constantly sensing being done by IoT devices, and that information is being fed back up to human machine interfaces. And so it's a world where you have to control a lot of these physical components on the production line, and also your sensing data to understand the current state of temperature, pressure, environmental conditions, all so that you can optimize the efficiency of the process and safety of the process for employees. That's just one example. A completely different example is in discrete manufacturing. An auto manufacturer, I talked with one of the German auto manufacturers. They have a robot that moves the car chassis from production line one to production line two. And if that robot fails, the entire production line stops. And so what they're doing is leveraging the human machine interfaces from this robot. In this case, the robot is the IoT device, in order to understand from a telemetry perspective some early signals of when that robot is going to fail, so that they can schedule a downtime window and proactively change the robot or maintain the robot. And so we see these entire range of examples between process manufacturing, discrete manufacturing. In water utilities, it's doing water filtration and water treatment. Within pipelines, making sure that the water pressure and temperature are correct, so you don't have a safety condition where the pipeline has a rupture in it. So an entire range of everything you could possibly think about with all of these applications in the physical world that are now becoming digitized to enhance business results and outcomes for the organization.
Grant just described 3 buckets. 1 being air-gapped, 2 being hybrid, and 3 being lights out. On the spectrum, where would Grant say most of the industries that he's looked at today fit?
That's a great question. You're right. It is total finger in the air speculation. But what we see is that a lot, because of the fact that you installed a $20 or $30 million production line, the technology obsolescence period may be 10 or 20 or 30 years. And it's not easy to change. Changing this because of the impact to operations and the safety implications has to be carefully engineered. And so it's not easy. It's not just, if you have a obsolescent asset, it's not just like, oh, we can replace it with a newer asset, right? It has to be done in a heavily engineered way to minimize risk to the business and risk to employees. And so my finger in the air guess is probably 70% are still living in the air gap world. They are maintaining some connections. And part of the problem is in the air-gapped world, a lot of these plants are completely flat from a networking perspective, meaning something happens one place, it's going to affect everything else within that plant. But they're starting to become connected up to the cloud to get some of those business results. We do see more and more projects in that middle zone. I've only seen a few early examples of kind of the world of tomorrow of fully lights out plants, but that's kind of the end state goal that every organization is driving for.
Claroty's report found that on average, 12% of these devices have been compromised or are vulnerable. There's a subtle difference between the two.
Yeah, it's a great tee up to talk about KEVs, which stands for known exploited vulnerability. So if you look, NIST maintains the governmental responsibility, and they do this. It's the de facto catalog worldwide of the National Vulnerability Database. So this is the authoritative source for all the vulnerabilities that exist. And within, if you did the math, what you'd find is that there's over 250,000 unique vulnerabilities that have been discovered by researchers or reported by manufacturers within the NVD. And traditional wisdom that you or I have been told has been no matter what, you've got to patch your criticals within X days. You've got to patch your highs within Y days and your mediums within Z days. And guys like me as a vendor have been asked by our customers to commit to those standards. Well, guess what? We have all been duped. I mean, at the time, this was traditional wisdom, and it does provide a good framing. But the reality is we're being set up for failure as a world community of cyber practitioners if we try to follow that guidance. Some of those vulnerabilities have compensating controls around them, and an external entity couldn't reach them. Or the ports may be closed on the operating system so that an exploit could not, even though the vulnerability is there, an exploit could not, lock and key open up that vulnerability. Which is why we have, while we still leverage CVSS scores within this report, we wanted to take a more pragmatic lens of how to look at it, which is there's something called KEVs. Now, CISA, about, I don't know, 2-3 years ago, came up with the concept of KEVs to say, look, don't look at the 250,000. Yes, you need to know that they're there, but what you really need to focus your remediation efforts on is about, at this point, I think it's 14 to 1,500 known exploits where it's a vulnerability that exists in the NVD, but there is a exploit, whether it's through ransomware or an attack toolkit that's been built to compromise that. And so if you focus, according to CISA, on this 14 to 1,500, that's going to be your best ROI or best return on risk reduction for whatever effort you place into it. And so that's where we focused, right, was for the start of this report. And what we found is it's 12% across the entire base. We kind of broke that down into manufacturing, logistics, transportation, and natural resources. And what we found is across those subsectors, it's about the same: 14% in manufacturing, 13% in logistics and transportation, and 12% in natural resources.
So is there any commonality among these different buckets, say a communications protocol?
It's a great question. I actually had the team pull together all of the KEVs that were in every organization. I bucketed them in terms, like I got to the top 10. And while you did find some KEVs were associated with like OT devices or IoT devices, the overwhelming majority were Windows systems or Windows applications. And this should not surprise us, right? Because Windows is very prolifically used within human machine interfaces and engineering workstations. I did the math, because I'm a data nerd, on the KEV database and found that just over 25% of the known exploited vulnerabilities are based on Windows operating systems or applications. And so given that 25% and the high prevalence, and sprinkle on top of that a little bit of technology obsolescence, that it's a clear message. But some of these vulnerabilities that some of the KEVs were like, I can send you a list offline, were like, things on Windows 7 or Windows XP. And yes, as for your OT practitioners on the call will know, there is Windows 7, Windows 95, Windows XP out there in spades. So, so while there are non-Windows based, they represent definitely a much lower percentage of what organizations need to be thinking about.
You've indirectly hit upon OT convergence, in that a lot of these OT vulnerabilities are also IT based. So people shouldn't roll their eyes and say, well, that's OT world, whatever. No, it's your IT world that's influencing the OT world, and you really need to be involved.
It's the terminology, I think, can sometimes be a little bit confusing. Like when we say OT, is it OT and IT? If there's a Windows asset, like an HMI within the OT environment, is that an IT asset or an OT asset? A laptop in the environment, is that an OT asset or IT asset? So one of our CISOs in the food and agriculture sector, he refers to as food production tech in order to avoid the polarization of terminology. And he said, look, whether it's an OT asset or an IT asset or a security or a camera that in mining, for example, you can't move the the CCTV is one of the most important assets. You can't pull a truck up. The automated trucks can't pull up and get their telemetry to pull up to the right location to limit spillage unless the CCTV is working. And that's an example of what I'd call mining tech, right? And so I think that changing terminology can help us get alignment and not make it a polarized conversation between different functions within the organization.
There's another thing in the report. It noted that a number of OT devices were capable of C2 server communications. C2 stands for Command and Control, and these are servers that are used by bots and ransomware for instructions. I find it kind of surprising because traditionally OT devices have had limited resources, obviously, with Moore's Law in place. As newer devices are being put in to replace obsolescence and so forth, we're seeing a greater capacity in the replacement devices. They are smarter and they are more capable.
I'll give you two lenses on this, Robert. What one lens is to say, if I'm a process control engineer and there's an emergency because production has stopped and I need one of the OEMs to access to help me troubleshoot, I may choose to operationalize a remote access tool without multi-factor authentication, or I may open up a pathway thinking that I'll shut it down when I'm done, but then I forget, right? And so we do see a lot of communication. A lot of these communications are from engineering workstations and HMIs, the places where telemetry needs to be harvested for outside entities to do their work or for assistance in maintenance. And a lot of times it's well-meaning, yet inadvertently creates a pathway for an attacker into the organization. The other place we see it is for assets lower down in the stack. Like we've seen a lot of building automation systems or within water treatment plants, connectivity directly to these assets. And so there are some OEM vendors that actually have the engineering workstation back at their site and the asset, they're connecting directly to the OT asset to make changes as well. So that's a reason why sometimes you'll see communication directly to an OT asset. In fact, the hack that happened from the I think it was the Cyber Avengers or Iranian hacking group against water treatment plants. They attacked a bunch of Unitronics. I think the PLCs were attacked. That was this type of attack. They were looking for assets that were communicating directly to the internet that were vulnerable.
So that's a great lead into the fact that the Claroty report identifies at least 3 different groups associated with nation states.
There are these terms that you've seen, like during the financial crisis. There were like the pigs, like Portugal, Ireland, Greece, and Spain, like cohorts of companies that fell into or countries that fell into a certain category. I call them the cranks: China, Russia, North Korea, and Iran. And I think gone are the days where the hacker representation is some dude in a hoodie. I think now we have to really be open-eyed and clear-eyed about the fact that a lot of the times these attacks are being leveraged by nation-state adversaries or their proxies in order to accomplish both criminal goals as well as geopolitical goals.
There's also a trend toward ransomware in our utilities, and that always gives me pause. It seems like public utilities have the least amount of money to spend on ransom. So there must be other reasons why they're being targeted.
So, for example, there were a rash of attacks both in England and the United States against water treatment plants by Russia. And one might think, why the heck are they attacking a small municipal water treatment plant and causing the valves to overflow or water levels to overflow? Well, I think it's two things. One is power projection, to be able to the ability to demonstrate and maybe make the United States think twice about actions to say that they can reach in and take advantage of both our digital footprint, but also our digital vulnerability. And second, I think in the case of a conflict, there's a desire to have the American population question the government's ability to protect them, right? We rely upon these as like dial tone services. If the water stops working in the United States for a day, it's a crisis. If it stops running in Russia, it's Tuesday, right? And so I think the societal expectations and societal reliance provides our adversaries an opportunity to demonstrate faults and exposures within this vulnerability. And hence why, a lot of the report is written around not around all vulnerabilities, but really focusing your efforts to ones that are internet connected, ones that don't have compensating controls in place, the ones that have exploits that can be attacked.
For the last few years, we've seen critical infrastructure getting more and more attention from government regulations. With the changing policies in the United States, is there some concern, or have we laid enough of a foundation and groundwork that should we be fine whether the changes happen or not in Washington?
The early days of the incoming administration, I'm actually optimistic that cybersecurity will continue to be a bipartisan effort. A lot of people are scratching their heads when the Biden administration issued an executive order in cybersecurity a week before the new administration came in. But that executive order, a few weeks in, has not yet been revoked. In addition to that, there's word that the CSRB, the Cybersecurity Review Board, think about that as the same way the National Transportation Safety Board reviews airplane crashes or train derailments and gets to lessons learned to help the whole industry. The CSRB, as well as the CIS Advisory Commission, were broken up and dissolved. By the way, that happens in every administration.
Right.
But there's early word that the Cyber Safety Review Board will be reconstituted. That's nothing official yet. And so, I believe that a lot of this is speculation, but I believe that the new administration will be highly focused, especially given the Salt typhoon attacks and Volt typhoon attacks, on trying to ensure that these are not viewed as polarized issues, but we try to be smart in terms of how we continue our journey here, given the strength of the adversary. Now, one other point, you didn't ask this, but what I view as the bigger threat is the reversal of the Chevron doctrine.
So let's talk about that. For background, the Chevron decision was handed down by the U.S. Supreme Court in 1984 and gave federal agencies the right to interpret vague laws. Usually it resulted in new regulations around, say, water or air quality or public safety issues that we've come to enjoy over the last 40 years. In 2024, the U.S. Supreme Court overturned the ruling, putting existing and new public safety regulations in jeopardy. Grant suggests overturning Chevron could have a chilling effect on critical infrastructure systems.
So again, while I see that the current administration is really concerned in terms of cybersecurity activities, Congress continues to treat this as a bipartisan issue. And I think important advancements will be made. There's kind of a sort of Damocles hanging over 40 years worth of legislation that's been put in place and 40 years worth of regulation that's been put in place. In essence, what has happened is that Congress writes laws, and getting to sufficient specificity can be tough sometimes. And so they have assigned the responsibility to the executive branch, the agencies, to then do a lot of the rulemaking or determination of how to operationalize and implement the legislation that Congress has released. Well, that's been the case for 40 years. It came out of an environmental case involving Chevron. It's referred to as a Chevron doctrine. The Chevron doctrine basically says that the executive branch has that ability to take the baton where Congress has left off. Well, just in 2024 and prior to that in 2022, there were two major pieces of legislation that went before the Supreme Court. In 2022, there's something that came out known as the Major Questions Doctrine, and in 2024, the reversal of the Chevron Doctrine. I'll take the policy wonkiness out of it. What it basically says is that if Congress is in legislation that's passed is not sufficiently detailed in terms of their intent, the executive branch cannot determine rules or implementation details, and they can be challenged from a legal perspective. And so we're waiting for the first, shoe to drop on this in 2025. That I believe there are going to be some legal challenges against potentially CERCIA, which is about protecting the most critical of critical infrastructure, the breach reporting requirements for covered entities for critical infrastructure, Potentially some of the TSA regulations that have come out in the freight sector, freight rail, shipping, pipelines, and airlines as well. So this is going to imply both existing regulations may be torn down and deemed not legal. It's also going to force Congress to be much more specific in legislation in cybersecurity. So they're going to have more cyber expertise. The courts are going to have more cyber expertise as well, because the courts are going to have to adjudicate to be knowledgeable on whether this legislation is in line or not with the congressional intent. That's what I view as a bigger looming threat to progress in government engagement to bridge the gap between the risk that exists within the country and the threat and that distant gap between that and the ability to control and protect these environments.
We'll see how in the next few years play out. One proposal is to remove all regulations entirely. I'm going to play the optimist and say, well, we've had enough of that foundation already, that the lack of regulations might be mitigated by the fact that we're just going to do the right things anyway. That may be mere inertia, and we'll continue to do the right things for a while.
It's a valid question. My sense is that while there will be a lot more bureaucracy that goes into it, so many of the programs that have been established during the Biden administration are foundational, bipartisan in nature, and I do believe a lot of the foundation is there. And I think that there's broad recognition that the manufacturers of software and the OEMs of OT tech are the ones that need to design the software securely. The asset owners and operators need to demand in a consistent way what good looks like here. That the government needs to step in and apply regulations as needed to bridge the gap. So I believe that there's enough, the zeitgeist of the time is that this is a huge problem that can impact national security, economic security, and public safety. And the government has a increased role to play, which I believe will continue to resonate and build upon the foundation that has existed.
So I'm sensing a thread from this conversation that it's really just maybe a matter of changing some of the terminology and to a degree making it more accessible to the people who are not generally cybersecurity experts. In episode 16, Josh Corman talked about his group, I Am the Calvary, and how they sponsor Hackers on the Hill to educate members of Congress on cybersecurity issues. And during the Biden years, there was even Hackers in the White House.
That's certainly part of it. It also involves changing methodology, as I said, from like CVSS to KEV or EPSS, which we didn't talk about yet, and we can talk about later if you wish. So it's using methodology. And a part of that is also asset discovery, having a good asset catalog so you can identify what is a zone that matters, what is in the production line. Taking it from production line to an asset level is a technological shift in how organizations have thought about this before. Like the security people think about it in terms of a group of assets or just a list of assets. The business thinks about it as a production line, right? So it's having that translation there. So I do think that there are some technical connection points. Another recommendation that we give that is not about terminology at all is really the belief I have that industrial organizations need to start thinking about moving to a segmented approach, like implementing segmentation. And I'm sure there are people on the call saying, what the heck is Geyer saying? But no, in order to mitigate risk, right? So I believe that you have to have an effective, whether you call it vulnerability management or exposure management program, you have to have one in place because there are always, whether it's a vulnerability or a default password or I just talked to a railway company that has 400 assets that they use to connect remotely into to then make changes to signaling systems. They all use the same username and password, right? That is not a vulnerability, but that's a hella scary exposure that exists, right? So again, back to my point, there's a lot of things there's a lot of vulnerabilities out there. A lot of technology is obsolescent, but you can't patch everything in a cycle time sufficient to mitigate risk. And patching is a kind of one-by-one effort. My thesis is that you have to be able to take entire classes of risk off the table, especially in line with this dissolution of the Purdue model. If you're thinking about machine-to-machine communications or cloud workload to machine communications, you need to have segmentation in place. You need to apply a zero trust model into this approach. And that's a heavy lift that I think needs to be done in stages. But ultimately, if the goal is Industry 4.0, where it's about automation to the nth degree, I see no other way to responsibly implement Industry 4.0 than doing it with a zero trust model.
So Grant mentioned EPSS. Can he talk a little bit about that?
Yeah. So a group of researchers at first, the Forum of Incident Responders and Security Teams, and the great organization, they had a work stream on this concept of exploit predictability. And the question is, what is likely to become the next exploited vulnerability? And therefore, can you start to look forward and patch things after you've done, the core kevs? How do you look forward down the road and start to patch the next things before they become a 0-day or before they become compromised? And so what they did a whole ton of data science. And they basically, and it's on the first website, the white paper, you can download it. It's amazing. It basically shows graphically that if you looked at the entire universe of vulnerabilities and you focused them on with a CVSS score of 10 or higher, and you patched them all, ungodly amount of work, but through some Herculean effort, you got it all done. It winds up that you would only have patched, and I think they took a 2-year look back, you would have only have patched 30% of the vulnerabilities that became kevs. Oh. And so your effort is enormous, your impact is low. And so they then, through kind of constant refinement, and I don't understand all the mathematics and data science behind it, but through all of these different indicators of potential exploitability, they were able to come up with a model. And I think now they're on their third version of the model that shows if you patched everything with an EPSS score of 8.8 or higher, I think they used, you would patch 84% of the vulnerabilities that became kevs in the future. And so the question here is one of efficacy, right? With the limited resources that we have, how do you ensure people are focused on the best bang for their buck? And like that's the whole body of work on EPSS, and we use that as well to help organizations make smarter decisions about patching efficacy. One other point, and we talk about this in the report, that when we kind of go down the funnel of number of kevs that we found, 12%, to what percent were linked to ransomware? That's just over 7%. How many of those devices had insecure connectivity? Kevs insecure connectivity, it's 0.9%. And how many are linked to ransomware of those kevs that have insecure internet connectivity? It's only 0.4%. And people might say, oh, well, Claroty, what are you making such a big deal for? It's only 0.4%. It's a small number of assets. But when you look about the spread of those 0.4 assets across the 270 organizations in the scope of our survey, it turns out that it's linked to 31% of those organizations. So 90 of the 270 organizations that we analyzed had a kev linked to ransomware insecurely connected to the internet. And it's a good news, bad news story. The bad news is an awful lot of organizations that represent critical infrastructure that are at risk. The good news is if they focus their effort on those small number of devices, you can take some of the biggest risk areas off the table completely.
So the report concludes with some recommendations. I wondered if Grant could walk us through those recommendations.
Yeah, I think that, core to this is changing mindset about how to approach vulnerability management, rather than thinking about it that, as I said before, that there's lots of stuff and you got to fix all your stuff. It's take an approach of an exposure management, meaning understand what matters most. One of our companies in the food and beverage segment does a lot of dairy production, and the most important zone in all of their factories is milk receiving. If that zone is down, nothing else in the plant functions. It is critical path. And so in the same way you kind of do a bow tie risk assessment, the key here is understand what matters most and establish that as the scope of your exposure management program. Yes, there's lots of other things that matter, but what are the things that will stop dairy production? What are the things that will stop steel production? And focus on those. The second piece of this is discovery. It's understand the assets within that place, understand coverage of security controls and understand effectiveness of those controls. And then based upon that, prioritize what things have compensating controls and therefore don't need to be prioritized and which things don't, right? So based upon controls and effectiveness, determine your actions in terms of how you're going to remediate. And then the key therefore and is then to mobilize the organization. I think core to this is getting out of the world of cyber speak to the business, right? Like again, a friend of mine is a CISO, one of the big semiconductor production companies, and he was talking with them about cyber. They didn't understand any of it, but when he asked, "What is the impact of the process failing at this point, or this point, and this point?" All of the process control engineers can not only talk about the impact on dollars and cents terms, they could also talk about, for output, they could also talk about wasted product of a silicon wafer if it went through this part of the process but didn't get to this part of the process. So I think key to this is about mobilization. It's when you have your risk register and catalog of things that need to be done. Again, if you've done it well, the business knows everything according to steel production is core to the business, so they're not going to say no to that. And you can help mobilize the organization by talking in dollars and cents terms of impact. You're talking their love language at that point. And that's, that to me is that whole process is core. So again, that is a different mindset than vulnerability management, which is just patching stuff. This is about mobilizing the business in a highly focused way that is in terms that engineering can understand and will really resonate with them.
I'd like to thank Grant Geyer for coming on the show and talking about his latest research at Claroty. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Join us on Discord. Search for Error Code Podcast to join the server, or go to errorcodepodcast.com to get more details. And tell me what you like, and even what you don't. I've got some great episodes coming up, including more on hacking water facilities. Subscribe today. I don't want you to miss out.